Hi, I'm David. I'm a 3D artist since many years and I specialize in character animation, rig and VFX. I use Maya and Houdini. I'll try to speak English in this video, even if it's not my mother language, so sorry for my English. If you don't like it, you can call and complain, okay? Today we will try to recreate the magical portal of Doctor Strange. It was a course that I gave in a school because I'm a teacher, and I'm now reusing it as a tutorial. So for this we will use Houdini. This course was given to people who never used Houdini before, so it's a beginner level tutorial. That's why you can hear me explain basic stuff about Houdini, about its interface, about how it works. I know experienced users will be annoyed by that, but in that case you can call me and complain, okay? In fact, this video is a mix between two courses. The first one was given on Teams, so it was remotely given. And that's why sometimes you see the Teams interface, because it allows me to read the questions in the chat and to answer them. And the second part of the video is in a real classroom. If you want more information about my services, you can visit my website, dreamcraftdigital.com. So that's it. Let's start this tutorial about the magical Doctor Strange portal. Let's start a new scene. You don't have to save the previous scene you were playing with. As soon as you create the new scene, you can save it. I always start by saving the new scene, even if it is empty. So then I just have to press Ctrl S. So now I'm setting the animation options, and as we are in Europe, the standard in Europe is 25 FPS. So that's what I'm setting up, and I press the button Save as Default so that all new scenes will have these 25 FPS. Then I close. And we have in the background this kind of gradient, white to blue. It's just like in Maya. And the problem with that is that when you create particles, you don't see well enough the particles you are creating. So we will change the background to black. And for that, we will put the mouse above the perspective view and press D. And then we can go to the background tab. And then we choose as color scheme dark. So that's it. It updates automatically. We will now create a new camera. As soon as we click the button, the new camera is set up in the perspective view. You can lock the camera so that when you move the camera with the Alt key, it will move it in the perspective view. And we can rename the camera. I always rename my camera as Cam Render, whether it's in Maya or in Houdini. And this screen up there is a bit like the channel box in Maya, so you can enter values to reflect the position and rotation of the object. And the values we will put for this camera to have a good point of view on the Sparks wheel. You can put the values I'm entering now. Translate X 0, translate Y is 1.2, translate Z is 6. For the rotations, rotate X is minus 1.7. Rotate Y and Z is 0. So let's continue. We will now create a light. And we have different choices for the lights. We have the point lights, spotlights, etc. And the light we will choose is a distant light. So click on the button, and as soon as you click on the button, we go in the point of view of the light, like if the light was a camera. The light appears in the network editor, and we have the properties of the light where we can set the coordinates of the light, and you can just type in the values you see on screen. Translate X is 0, translate Y is 4, translate Z is 8, rotate X is minus 20, and the two other rotation axes are at 0. So if we want to go back to the camera we have created before, we can choose, we can go to the menu that is on the top right corner of the viewport and choose the camera name we created before, Cam Render. We'll need to navigate freely in the viewport, so we are not obliged to keep the Cam Render locked. You can keep the button unlocked. And as we navigate in the Houdini default camera, we can see in the viewport the camera and the light we created before. So now we will create an object on which we will put the particles to create the Doctor Strange portal. So the first object we will create is a tube. In Maya it's called a cylinder, and in Houdini it's called a tube. And after you press the button, you have to put your mouse above the perspective view and press enter on the keyboard, so the object is created right at the center of the scene. The tube object node has appeared in the network view. We will rename it Sparks Wheel. With this node, there is nothing much to do. What we should do is enter the geometry level so that we can set up the object and then add many more nodes to achieve what we want to do. So in the geometry level, we find a node that is called Tube 1, and this is a construction node. It allows us to do different things, and the construction node is something that must be set up carefully. The first thing we must change is that the tube is facing the y-axis of the scene, and that's not what we want, because we want a particle wheel that is facing the camera, just like in the movies. So in the orientation parameter, we choose the z-axis. If you want to watch the object you are creating in a closer way, you must put your mouse above the perspective view and press space F. So there is a new problem, is that the portal is in the ground, so it must be above the ground, and that's why in center Y we will enter 1. So now the cylinder is above the ground, which is what we are looking for. The default unit in Houdini is the meter. So with the radius parameter, we will set up how big is the portal, and to put it at the human size, we can enter 0.75 in both input boxes. The height of the cylinder is how deep is a cylinder. We will now add some subdivisions because, as you can see, there is not enough polygons in the shape, and the shape of this cylinder is very angular. In the rows parameter, you can input 10, and in columns, you can type in 40. So now we will enter a formula that will allow us to make the wheel turn continuously without any need to input animation keys. When we will press the play button in Houdini, the wheel will turn forever, in a way. So we have to modify the rotate input boxes, and there is something I want to show you before doing that. It's kind of a tool that exists only in Houdini. So if you put your mouse above the rotate ZEEE input box, you press the middle button, you keep it pressed, and you have kind of a ladder. We call this a ladder. And you keep the button pressed, the middle button pressed, and you move the mouse left and right, and you can see that the values will change. You can also put the mouse above the 1, and if you move the mouse left and right, you can see that the value increases or decreases by 1. So it's very handy to have that because you can visually see the feedback of what you do in the input box. So let's start the formula. So you type in the $sign, capital F, multiplied by 3. So multiplied is a little star you have on the keyboard. $F is a variable. It means the current frame. So for example, if you are at frame 5, $F is 5. And then this value is multiplied by 3. So this formula uses the current playing frame and take the number of the frame and multiplies it by 3. And this is why when you press the play button, the wheel will turn because the timeline will turn as well. So this automatic rotation we have on the wheel is not the final speed of the particles we will have in the scene. At a later stage we will add more nodes to make the particle travel very fast, and this will be the final visual effect that we will have. So let's start to alter the shape of this cylinder. So far it's much too clean and much too regular, so we will add a node that will disturb the shape, and it's a node that is called mountain. So as you can see, the mountain node is still called mountain in the latest version of Houdini, but in a way it's just a noise that we use. And as soon as you connect the mountain node, you can see already some kind of deformation, which is very cool, but we have to set up this mountain node. In the amplitude, you can type 0.3. Element size should be set at 1.2. offset 0.5. So this node is usually used to create mountains, but you can use it to deform any objects you want to deform. So we want to add another effect. The deformation we created now should not stay the same in all the timeline. We want it to move and to be animated. That's why we check the box animation. And then we will set up the parameters for this animation. In pulse duration, you can type in 2. Let's see what it does when we press the play button. So if you feel this cylinder is too much deformed and too much wild, you can modify the parameters again. These are my parameters, but you are not obliged to use exactly the same values. But you should keep the visual of this wheel as something spectacular, because this is what people want to see. So now we will use normals. The normals on any objects, of course, exist since the beginning, and you can see the current normals by pressing a button at the right side of the perspective view. You have a button for point normals and another button for polygon faces normals. We will use now a normal node. So what is it for? The first thing it is used for is to clean the normals, to make them a bit more better looking. And the second thing that it is used for is, if we put this node, we can now use the normals in VEX code. In the parameters of this node, in add normals to, you choose points. So in Houdini, vertices are called points, and in Houdini the UVs are called vertices. It's a bit strange, but that's how Houdini works. I wish they could change that and make it more industry standard. You also have a choice for primitives. So in Houdini, a primitive is 3 different things, and one of these 3 different things is a polygon face. So once again, the language in Houdini is different than in other 3D applications. We now take a scatter node, and the scatter node, what it does, it converts every points, meaning vertices, into simple points. So the points that are on the surface they become floating points. They become points that are just not attached to a geometry, but they still rely on the base geometry. So in the scatter node, we will choose the number of points. This is done by modifying the number in force total count. So later in the process, we will have many points, like 600 points or maybe 1,000 points. But for now, we want to keep this number low, because it allows us to work in an easier way and to have things more simple. That's why for now we just put 50 points. So now we will start, as I said before, the VEX code, And for that we have to choose a new node that is called attribute wrangle. So let's start this vex expression. And this formula is very simple. It is just a code that will explain, that will state that the velocity that we will use on the particles later are based on the normals. Normals are vectors, and velocity are vectors too. So let's explain this vex code that I just typed. You first have lower caps v's, and these mean that the variables that we use are vectors, okay? So 3 values into 1. And then you have the @ sign, and the @ sign is the prefix of a variable. So you have here 2 variables. One is v, lower caps v, which means velocity. And the second one is @n, capital N, which means normals. So as I said, it's very simple. Velocity is based on the actual existing normals. So these 2 variables exist in Houdini. They are part of the system. So why do we state that the velocity is based on normals? Because when you display the normals, you can see that they are based on the point normals of the base cylinder, the base tube, and all these normals are going outwards. This direction of the normals going outwards will be used to push the particles outside of the cylinder, and that's why we are basing our first velocity on the existing normals. At a later stage, of course, the particles will not only travel outwards in the direction that you are seeing in the screen now, but they will then be taken by some other forces that we will put in place. Some kind of spiral force that will make the particle move in a circular way as well. So everything is set up for the particles. So now we will bring a new node that will generate particles. This node is called Note Pop Music Pop Network. Okay, so you can connect it and put the display flag on the popnet. If you press the play button, you can see that all our points have disappeared. And that's because we have to set up the pop network. So we double click the pop network and we enter this node that is in fact a whole network, a new kind of network, which is called dynamics. As you can see, there are already many nodes that are present. And we must set up each of these nodes, and also at a later stage we will add some new nodes. So the first node that we must select is a source first input, and the first thing I want to do is so the points are back. We can see the points now, but they are blue. Why? Because there is a guide tool in this node that is supposed to make us see the particles in a better way, but it's not good, and we don't want to have the points in blue, especially because at a later stage we will put on our own colors on the particles. Okay, so you have to uncheck guide, and now we are in the source tab of this node. In emission type, you choose the all points. And once again, our particles are back in the viewport. If you press the play button, you can see that something is happening. Okay, it's not exactly what we want, but at least it looks good, okay? It looks like some kind of galaxy, and it's fine. Maybe we can use it for another effect we want to do, but it doesn't look like the Doctor Strange portal, so we have to set up more things. So if you want to view the effect in real time, you have to press the little clock that is under the play button. So we have to modify once more the options of the source first input to make it look like what we want to see. So the first thing we have to do is to go in the birth tab, the second tab, and we will set up what happens when each particle comes to life. You have 100 in life expectancy, and these are seconds. It means that each particle have a lifespan of 100 seconds. You can see in the YouTube video that the spark wheel is more narrow. The particles don't live for 100 seconds. So that's why we lower the life expectancy to 0.3 and the life variance to 0.15. So this means that some particles will live half a second and other particles will live a quarter of a second. This is good because it gives an organic look on the effect. And as you can see, when you press the play button, the particles travel less far and they stay around the wheel. If you want to see the trajectory of the particles, there is a button for that on the viewport on the right side. It's the button is called Display Point Trails, and you can see kind of a trail behind each point. It reminds us in a way of a comet or a shooting star. Let's start this effect that will bring the particle inside a maze. We put the source first input node a bit higher in the network so we can place some new nodes. And the first node we will add is called Pop Axis Force. So let's set up this force that we brought now. This node will make the particle turn very quickly. So let's start by the Shape tab. You have in the viewport a guide that shows around what axis the force will be applied. And as you can see, as we did in the beginning with the tube, this guide is stuck on the ground. So we have to put it higher, and we will use the same value as for the tube. So center Y must be set to 1. And for the direction, it is the same. So for the tube, we chose the Z direction, and we must choose the same direction. That's why in the input boxes, I enter 0, 0, and 1. As for the radius and height, we can put it both at 0.8. So once again, it's a bit the same size we had for the tube. So the settings for the shape tab are finished. Let's go to the speed tab, and the most important parameter here is the orbit speed. So the orbit will make the particles turn around the center axis, and for now the orbit speed is a bit too low. It will not give something very interesting. So I think we can increase the orbit speed and put it at 10, and then we play with the play button. If you see the timeline colored in orange, it means that the cache is not actual. You have to wait for the timeline to go back to frame 1 for the cache to be renewed, and in that case the timeline becomes blue. The blue stripe occupies the timeline left to right. If you see that the blue stripe does not reach the end of the timeline, it means that you don't have enough RAM memory, and that's why when you use Houdini you have to use a computer that is very powerful with a lot of RAM. So for now the particle motion is not very cool, it's not very good looking. So we have to make more adjustments. So the particle should not move only around the center. It's possible that the particle can also have a motion that pushes them closer to the camera. And that's why we will modify now the lift speed. So usually lift speed is to raise particles towards the y-axis of the scene, but this time the general direction is Z. So lift speed will bring the particle closer to the camera. So here I made a mistake. I type 0, I forgot the dot, and then I type 75. So the particles now are progressing a bit toward the camera. As for the suction speed, so it's a bit the opposite of the orbit speed. Orbit speed makes the particle go around the circle, but suction speed will attract the particle towards the center. So it's important to modify this value too, because it makes the effect more realistic. Let's put the suction speed at 1.2. And as you can see, the motion is a bit more interesting now, although the settings on these particles are not final. So let's play again without the velocity button. And I think we are getting closer to the effect we want to do. So now we will go to the third tab, which is called Fall Off. The soft edge that you see on top is the percentage when the inner strength becomes the outer strength. So it's a speed multiplier, and when the particles are born, they have the inner strength percentage of speed. So 1 is 100%, and after the soft edge, which is a percentage of life, after the soft edge passes, the particle adopt the outer strength, which is a percentage of the speed, which is set up in the speed tab. So what I am doing now is, after half of their life, 0.5, the inner strength that was 100% of the speed goes to the outer strength, which is 3/4 of the speed. So the result is the particles are starting quick, and after half of their life, they slow down to 55% of their original speed. This setting gives a better visual to the motion of the particle. We will do now what I talked about before. We go back to the scatter node and we will add the final amount of particles in the simulation. I chose 750 particles. This amount also depends on your computer. If your computer is powerful, you can put 1000 particles. And if your computer is a bit older, you can put 600 particles. So now we will add a new node that is called Pop Wind. This node, as its name says, will add some kind of wind on the particles. You connect it between pop axis force and wire pop into here. It will give a more disturbed motion to the particles, and it will also slow down a bit the particles. So the first setting is air resistance that you put at 1.5 instead of 1. So the amplitude is at 0 for now, which means the noise is not enabled. If you put it at 1.5, you will see these effects on the particles. So let's wait for the timeline to turn back to blue, which means the cache is actual. I think we can also modify the swirl size that you can put at 0.7. And if you wish, you can try the other sliders and see if it's good for you. And don't forget the goal of our tutorial, which we must have something that looks like the magical portal we see in the videos. So now we can go back to pop axis force and uncheck guide, because the guide is not useful anymore and it annoys us in the viewport. You can also uncheck the grid with a button in the top right of the viewport. So let's continue. So now we will bring a new node that will take care of the colors of the particles. This node is called pop color, as you can guess. In a way, pop means particles in the Houdini strange language. So this node will be used to put colors on the particles, but also some kind of gradient color and alpha also, which will make the particle more transparent as they reach their end of life. So let's start by the tab color. In a later stage we will use the alpha tab. So for now we have some kind of purple color. The color type is constant. It means that there is no evolution of the color along the life of the particle. So let's put ramp. So you can see in the Vex expression that the gradient that you see here, that is called a ramp, is based on the age of the particle. That's what the Vex expression means. So we will put some colors that look like the Doctor Strange thing. So at the left side of the gradient, you can see several buttons. and a small triangle that you can click, and it unfolds the parameters for each marker. So far we have only 2 markers. So let's select the first marker that is on the top left of the gradient. And let's put a color that is kind of orange. So you can put these values, or you can click the colors rectangular button to open the color selector. You must put some bright colors. If you put some dark color, you will not see the particles, and it will not look good. It must be bright to look good. So now we are choosing the color for the right marker, and it's a red. Okay, so it must looks like sparks, and sparks are very hot, so we put some color that means the sparks are in a way burning. So the particle is bright, it's yellow-orange when it is born, and then when it reaches its end of life, it becomes red. So it's less and less bright, it's less and less visible, and it gives a realistic aspect to the simulation. If you want to choose colors that make you think more of a sci-fi or a magical effect in a role-playing game, you can choose some colors like blue, green, as you wish. And you can also put a third marker if you like. So let's go to the Alpha tab. So the Alpha deals with the transparency of the particles. So what we will do is make the particle visible not as soon as they are born, but maybe a bit later. So in a way they take shape after their birth, and then they are visible for most of their life, and then at the end of their life they become more and more transparent. This is a kind of gradient we should set up. So check the update alpha checkbox, and then alpha type you choose ramp. So an alpha gradient is only one dimensional. That's why you have only one line here that you can alter and modify. When the marker is at 0, it means the particles are completely invisible. And then when the marker has a value of 1, the particles are fully visible. So let's click again this triangle, which help us to set options for each markers. So this marker has a position of 0. It means that the marker is at the top left of the gradient. And the value will stay at 0 because when the particles are born, as I said, they must be transparent for some time. if we press the play button, we can see that so far it's not optimal. It doesn't look very beautiful, and it's not very logical for what we want to do. So to get a good visual effect, we must have 5 markers. You can click on the line to add a new marker, and I will give you some values that work for this effect. The second marker has a position of 0.1. This means 10% of their life. So after 10% of the length of their life, the particle will become fully visible. That's why we put the value at 1. So let's add now a third marker. It will have also a value of 1, so the particles are still visible. And this marker will be positioned at 0.5. So when the particles have lived 50% of their life, they are still fully visible. So the fourth marker will be next to the end of the gradient. The exact position is 0.9, so this means 90% of their life. And the value will decrease a bit. It will be 0.7, which means the particle is becoming a bit transparent. And the fifth marker doesn't need to be created because it is already here. Its position is 1, so it means it's fully on the right side of the gradient, and the value is 0. So the particle becomes fully invisible at the end of the life. So there is a last setting that we can do. It's not very useful, but it's better. You can see that the line, the curve we have now is very cubic. It's not it's angular. It's not good looking. So you must select each markers, and for each of them you put the interpolation on monotone cubic. So then it's kind of a spline curve we have, and maybe it's better for the animation, but everything goes so fast, so even if we don't do that, the effect will still be good. But okay, it's kind of a perfectionist attitude here. So if you want to check what the alpha does in your simulation, you can uncheck update alpha and run the simulation, and then you can check update alpha, and you can see the difference between the two. So the result of this effect is that the wheel is a bit less thick. It's more realistic. So now we will take care of the gravity. So the particles have some kind of weight when they are blown out of the wheel. They kind of fly for a while, and then they will come back to the ground. The gravity we will add is a bit, it's not the real gravity on planet Earth. It is something a bit more discrete, something that we feel a little bit, but it will not transform completely the motions of our particles. So you can choose a gravity node, you connect it between the pop solver and the output, and the setting you see on top of the screen is the Earth gravity, the default gravity. But this is too strong, because if you play the animation, you can see our wheel is too much deformed now, and there is a part of our wheel that goes underground, which is not very good. So we lower the gravity at -2, and Now it looks better. We can feel a bit of gravity, but it doesn't transform completely the visual effect we want to get. So now we will prepare the real ground, because if you use this effect, you must use it in a 3D scene with a real ground, and it would be cool if the sparks rebound on the ground. So we have to create a simulation ground, and this simulation ground can be part of the effect. But before we do this simulation ground, we have some other settings to do. So far we can see that the motions of our particles are fine. It looks good, okay? But there is a way to make them look a bit better. So let's go back to the geometry level and select the pop net. And there is a setting on this node that maybe you don't know. So in the parameters, you have a simulation tab. There is a substep parameter which is used to increase the precision of the simulation. So the trajectories of each particle will be more precise if you increase this value. If I put the substep at 5, you will see that the aspect of the particle of the motion are much better. So before pressing the play button, save your scene, because sometimes if your computer is not good enough, there can be a crash. So it's better to save the simulation before, and then when you push the play button, you can see that the motion is much more impressive. You know, it looks really cool now. It looks like a real fire wheel or something. And with this new steps setting, Houdini is computing the new cache. As you can see now, it's creating the blue stripe. But as you can see, my blue stripe cannot cover my full timeline. This means that I don't have enough RAM memory, and I need to decrease the substeps to 4. So now I click again on the play button. This will recreate the RAM cache, and I will check if this time the blue stripe will cover the full timeline. So far, so good. Success. So now I have a full cache for the full timeline. So another thing that's good is that the simulation seems more solid. You know, there is more matter to the simulation, and it looks much better. So this is a workflow that you should do when setting up simulation scenes. First, you put a number of particles that is low, like a bit before we put 50 particles only. Then you start with a substep of 1, and then at the end it's not only increasing the particles is not the only thing you should do to have a better good looking simulation. You can also increase the substeps, and in that case you're not obliged to put so many particles in your scene. So I'm selecting again the tube node because now I want to create a simple animation. I want to get the portal to open, meaning at the beginning it should be small, and then the size of the magical portal grows and reaches the size that we have now. So for that, we will just animate one parameter in the tube node. Put the display flag on the tube node so that we can see exactly what we do. And the parameter we must animate is the radius scale. For now, the radius scale is at 1, so we will keep this value and we will put a key somewhere on the timeline. So let's decide that the portal will open in 1 second. So it needs 1 second to open. So let's go to frame 25 and let's put a key. To put a key on a slider like this, you can press Alt on your keyboard and left click on radius scale. You can also right click on the number, go to keyframes and set keyframe. When you put a key on a value like this, if you are on the right frame, the input box turns to green. When it is green-blue, this means there is a key somewhere, but not on the frame we are in now. So let's go now to the first frame and let's put a small value like 0.01. Again, you can press Alt on the keyboard and left click the radius scale. So we cannot put really 0 because at 0 in the scale, the object completely disappears, and for the scatter to work and for the pop network to work, it needs to have a surface. That's why you don't put 0 in the radius scale, but instead you can put a very low value. So by default, when you animate something, the animation curve has a slow in shape, and it's something we don't want to do. So let's select again the tube node and go to the animation editor, which is a second tab on the left side of the interface. And you can see the animation curve now of the radius scale. If you want to see in a good way all the keys of the curve, you select both keys and you press G on your keyboard. Then you can select only the first key and you can change the tangent. So there is no slow in. It's a constant speed at the beginning, and then little by little the speed will decrease, reaching the 25th frame. So here I am repeating what I am doing because a student asked me to show it again. So let's see what this animation gives when we have all these new parameters. So if we press play, we can see the spark wheel grow little by little and reach its final size. So the first time you play the animation, the playback is very slow because Houdini is at the same time creating the RAM cache. But then when the timeline goes back to the first frame for the second playback, it's the real-time playback. So there is something else we can animate to improve this portal opening. It's the scatter. We can animate the force total count parameter. So at frame 25, let's put a key with what we chose as a number of particles. And at the first frame, we can enter a lower value like 50 and put a key also at frame 1. So it's a bit better, but we can decrease again this amount. Let's put 5 particles at frame 1. And as you can see, when you put a new value on a frame that on which there is already a key, you don't have to put a key again. The new value is taken into account by the fact there is already a key at this frame. This is the difference with Maya. So as you can see, at the beginning there is only 5 sparks, and then the amount of sparks increase and the size of the wheel increase as well. So now let's talk about what I said before, the collision with the ground. This is something we must set up inside the simulation node, which is called PopNet. So let's create a ground that's only useful for the collision of the particles. This node is called ground plane. So you must put the ground plane at the left side of the gravity node, and both of these nodes must be connected inside the output node. And as you can see, there is only one input connector in the output node. So the only way to do that is to add a new node that is called merge. So we have to link the ground plane and the gravity inside the merge, and then the merge inside the output. But there is one thing that is important, is that the ground plane must be connected first and the gravity must be connected second. So we will cut the connection between gravity and output, and for that you have scissors. If you press the Y key on your keyboard, the Y key looks like a scissors. You keep it pressed and you can cut the connection like this. Then you can connect ground plane inside merge, and then at the second time you connect the gravity inside merge and then merge inside output. So there is kind of a ground that appear here. It's not a real ground. It's not supposed to be visible. I think the system should work now. Yes, you can see here that the particles are rebounding on the ground. So it looks fine. It's okay. Let's go back to the cam render to see the effect. The gravity force is at now at minus 1.7. You can increase this value if you want to see the effect of the particles bouncing on the ground. So we want the ground plane to be invisible because it does not look good. It's only useful for the bounces. So you can select ground plane and uncheck display proxy geometry. So now you go back to the geometry level Sometimes you will see in the renders that the ground that we just made invisible will still come back, so it's a bit annoying. And to be sure that the ground really will never appear, you can select the PopNet, go to the parameters, you go to the Object Merge tab, and the object that will appear from this PopNet node is all objects, and all objects is the star. So the star is a wildcard, it means everything. All objects inside the PopNet will be visible in the scene. But if you want to keep only the particles and avoid displaying every other type of objects, you can just type pop star, okay? So now if we want to go towards the rendering, we must have a material on the Sparks wheel. So far we have a basic material that is just for the viewport, but it's better to have a real material. We will use today Mantra, but maybe I will do a follow-up of this tutorial with Karma. Let's go to the material palette. We can choose the material called Principal Shader. Drag it to the right side of the window, which is nothing more than the matte context. So the icon of this shader is a Disney castle, because it's a Disney engineer that invented this material. So with this material principal shader, we will do some settings. And the first setting we do is to rename the material. The name of the material is Sparks Matte. So let's set some first options. The base color, it's better to make it white. So you can input one in each of these four input boxes, or you can use a color selector. If you want to put the material on the Sparks wheel, you just have to drag it from the network window to the viewport on the Sparks wheel. If you want to check the material is still in place, you can go to the Obj context, select the Sparks wheel, go to the Render tab, and check what's written in material, in the line material. So this is the material we chose. So now we will do some settings for the rendering. With the Sparks wheel node selected, you stay in the Render tab, and you will set some other options in this tab. But first, I want to see what I do when I modify some rendering options. I will go to a frame that is spectacular, like the frame number 100. And then I will go to the render view above the viewport, the render view tab. So let's choose the right camera in this window and click the render button. You must wait a bit. The render is a bit slow to start. It's true that Mantra is a bit an old render engine now, and I don't think it is still updated. When the render starts, don't touch your wheel button of the mouse because there is some kind of bug. And that's it, we have our first render. Does it look like the Doctor Strange magical portal? I don't think so. It looks like a candy necklace or something else, I don't know. Something inside the body, a disease maybe. But it doesn't look like Doctor Strange's portal. So we have to change some things. So in the parameters for the Sparks wheel object, we have subtabs for inside the render tabs. Let's go to the sampling tab and we will start to deal with the motion blur. In Houdini, you set up the motion blur in 3 different places, and the first of these places is the object. So you put velocity blur, but so far you cannot see the motion blur, but you will see it later. Now you go to the subtab called geometry, and you have here a parameter for the point scale. This is why our particles look like candies, because they are too big. Okay, each particle is always a sphere, but this sphere must be very small. So the setting I chose is 0.075. Now it looks more like the particles we want to get, but it's a bit dark. Okay. So now is the start of the second course I was giving in a classroom. That's why what you see on screen is not exactly the same as 5 seconds ago. So let's go back to the Sparks wheel object, and we choose a shortcut to the material settings. So in this course I didn't put the base color white yet. So that's why I must choose again the white color. So now what we will do is to remove all the settings that are not useful for particles and that could slow down the render. Like for example, roughness. We don't need the roughness setting. We can put it at 0. Reflectivity must be put at 0 also. As we can see, the colors are bright, but maybe they are not enough bright. It's not impressive enough. We have a parameter here called albedo multiplier. It's kind of a lighting booster. And we can increase this value, put something maybe extreme like 10. But it's not good because it's too much, and there is a kind of a burn effect on the visual of the frame. So let's decrease it. Let's put it at 5 to check. 5 is still too much in my opinion, because the yellow color is dominating the frame, and it's not. We cannot see the gradient. The gradient is not fully active. So maybe 2, 3, 1 is okay. So I put it back at 4 to check. So here I am testing 20. It's not good. I think a value between 2 and 6 is okay. So let's go to the out context, which is a context that is used for the rendering. You can put one node to prepare the rendering, or you can put different nodes. In the out object, there is already a mantra IPR node, because when you click on the render button in the render view, it will generate automatically a node for the rendering. So it's nice to have different render nodes in the out context. For example, you can have a node for the mantra rendering, another node for the karma rendering. You could have a node for one camera, a second node for another camera in the scene, or you could have a node for the low quality rendering, another node for the production level quality. But for this tutorial, we only need one node. It's okay. The first setting we must do with the mantra IPR node is to avoid rendering only one frame. The chosen frame now is 100. We don't want to render only this frame, so we choose render frame range. By default, the first and last frame are the same setting we put on the timeline. If you click on start end, you can see the expressions that are behind these values. $f start and $f end are variables that exist in Houdini. So now we will deal with the camera. So for now we have a setting here that is not real. There is no camera called cam1. So we must go to the object chooser and choose the camera we have created at the beginning of this tutorial. For the output picture setting, so it doesn't look at all like what you have in Maya. And this line is full of variables that we must explain. So the first variable is $HIP. So what does that mean? HIP means current scene, and $HIP means the current folder in which there is the current scene. So for example, if our scene was in this folder, so let's go now find the real scene that is opened inside Houdini now. This is my Houdini project. Inside the project I created a folder called scenes, and this is the scene that is open now. And it means that what you see in the File Explorer address bar is the folder which is represented by the $HIP variable. So according to what we see in the path of the final render image sequence, from this scene folder, Houdini will create a subfolder called render, and then inside this subfolder it will create the images. So the first variable is the $hype name. It is just the same name as your current scene, which means every picture in the image sequence will be named as your scene. So then we have a dot and then $OS, which is the name of the current node. So the current node is Mentra underscore IPR. And the next variable is $F4, which means the current frame on 4 digits. So the first image in the sequence will be called 0001, the second will be called 0002, and so on. So then you have the final dot and the file extension, EXR. So this file type is a professional image type. It's used by the big studios like Pixar, ILM, etc. For us, it's not very useful to use this format because even if it is very good, it's a bit heavy on the hard drive. So let's just choose PNG. So in my case, I work in a project which has the scene subfolder. And in this project, I also have a render subfolder. So I will adapt the path of my output images for them to go inside the render folder that I already set up. I don't want Houdini to create a render subfolder inside my scene folder. So now let's talk about the option overwrite existing frames. It's better to take skip files that are valid images. If your render is interrupted and if you start it again, it will not erase and replace the images that you have already rendered. It will start from the last render frame and it will continue from that point. So if you have a render that should run from 1 to 250, and if the render is interrupted at frame 100, when you restart the render, it will render the frames from 101 to 250. So back to the camera options. This is the one of the 3 places where you set up motion blur in Houdini. So you have to go in the sampling tab, and you must increase the shutter time. If you put 0.9, you have longer trails in the motion blur of the particles. So let's go to the rendering sub-tab, and you must check the allow motion blur checkbox, because as I said before, it is a second place where you set up motion blur. And now you can start to see the motion blur in effect inside the render view, which is cool, looks cool. To speed up the render, you can also increase the noise level. As you know, modern render engines are very good looking, but they have a lot of grain. So if you want to accelerate the rendering of the particles, you don't need to remove visual grains from the render, because everything is so small and so moving so fast that it's not useful to have a precise setting for noise level. I choose to set it at 0.1. So let's see the next settings now. In the limits subtab, so the reflection limit, So for example, if you have 10 mirrors in a scene, Houdini will reflect each mirror in another mirror, and beginning from the 11th mirror, it will not render the mirror reflectivity, and it will just be a black rectangle. So it's not very useful for the particles, and we can decrease it to a setting of 2. Refraction limit, it is a transparency. The same thing with glasses. So if you have 10 glasses, you will see through the 10 glasses, but from the 11th glass, it will not render. It will be a black rectangle. So once again, it's not useful for the particles. We can put 2 in this setting. So everything is almost set up, but we must go back in the obj. I want to show you how to render in a correct way when you have particles in a scene. And for that we have to put in place a disk cache. So let's go back to the obj context and enter inside the Sparks wheel node. So we already have a cache. As I said before, it is the blue stripe on the timeline. This is a RAM memory cache. But for the render, we also need a disk memory cache. And for that, we take a node that is called file cache. We must set some things up inside this file cache. First, you select the file cache and you put the display flag on the file cache. This file cache node will allow us to write on the hard drive many files that are a cache sequence. So it's a bit like an image sequence, but it's only for the simulation. So the first setting is the base folder. So as usual, Houdini will use the $HIP variable, which means that from the folder where the current scene is opened, Houdini will create a subfolder which is called Geo. So in the line that is a bit above base name, we have the name of the sequence. You must uncheck the version checkbox because it will create too much nested folders. The disk cache creation is very quick because Houdini takes the RAM cache files and it just copies them to the hard drive. That's why it's very quick. So this is the final setting inside my file cache. We will now take a new node called delete. And this new node is used to kind of deleting the popnet. So the popnet, of course, will not be deleted. It will still exist inside the scene, but it will not be taken into account when we play the simulation. The only thing that will stay in the playback is the file cache. So we modify the option for the delete node. So far the pattern means that the delete is deactivated. A star and an exclamation point means that it does nothing. But if we remove the exclamation point, it will delete everything except, of course, as I said, the file cache. And as a result, the playback will be quicker because it will prevent Houdini from computing the popnet each time. So, of course, we still have the blue stripe on the timeline, which could mean Houdini is still reading the RAM memory cache, but in fact it is not reading that. It is reading the files on the hard drive that come from the file cache. And as usual in Houdini, we always end our networks by a null node that we call out. So that's it. We have finished everything we needed to do in the object context. So now we must go back to the output context. Let's talk a bit about some other options inside the Mantra IPR node. These options are dealing with the camera. So if you click the shortcut button, you go back to the camera parameters. And these camera options will allow you to choose the final rendered images resolutions. For this, you must go to the View tab, and in the black arrow at the right side of these parameters, you can find some presets. So now everything is ready. So you can save your scene, and you can go back to the Mantra IPR parameters, and you just have to click on Render to Disk. A window pops up. It shows the render progressions. And if you don't want to see always this window on top of the other windows, you can uncheck on top. So now the rendering reached frame 155. So just to check what's going on, I click on the interrupt button. And let's go to the render folder. And there I can find the images that I created. So we can see that the image names are the same as what I chose inside the rendering options. The last image is has a size of 0 kilobytes, so it's not a complete image. Let's delete it. And there is also another file which is used by Houdini to construct the image. It has the same name as the image it is building. And at the end, you have the file extension Mantra checkpoint. So we can delete it also. So the next step is to check how does look this image sequence. So we have a side effects application called mplay. It's also called the image viewer sometimes. So I'm looking for my image sequence. So the image sequence is only one line. which is handy. It's like if it was a folder. Let's click on the load button. You can put the correct FPS. And when we click on play, we can see the image sequence. It's like fcheck in Maya. Let's go now to Adobe Premiere. So we can create a MP4 video of our render. So let's create a new Premiere project. Let's save the Premiere file. So now we will import the images we created before. So we have to click on the first image to select it, and we have to check image sequence. So you can double click on the imported image sequence to see what it does in the left side monitor. Then you can drag the image sequence on the timeline, the Premiere timeline. And then you can go to the Export tab. You can modify the name of the MP4 video. You can choose the destination folder, like for example the video subfolder of your Houdini project. The other options are good, you can change them if you want, but by default they are okay. You can choose the new video encoder. You can uncheck audio because we don't have audio, except if we put a music. And you can click the export button. You can save before you click the export button. And this is the resulting video. So that's it. This is the end of our video tutorial. This was my first video tutorial, so it was a bit messy, and I had to dub the French voice of my courses, so maybe it was a bit chaotic. But the next tutorials I hope will be better. I hope to release many more video tutorials like this. If you want to see what I do as a 3D freelancer, And as a teacher, you can go to my website, dreamcraftdigital.com. Have a nice day and have a good life. Bye-bye.